Let us solve a few counting and probability computation problems to get a better understanding of the concepts of probability. So let us say we need to make a 4-digit combination to open the lock on the garage door, and we are only restricted to use 0, 1, 2 and 3 digit to make these, and another restriction is these digits should not repeat or they should be different in the combination. So we have got 0, 1, 2 and 3. So first digit could be any one of the four: 0, 1, 2 and 3. So we have four possibilities. If we choose 0, then we have the 3 digits left. If we choose 1, then we have 0, 2, 3 left. If we choose 2, we have 0, 1, 3 left. And if we choose 3, then 0, 1, 2 left. So for the next digit, only 3 choices are available. Similarly, if we have chosen the first 2 digits, there are only 2 more digits left to be chosen for the third digit. And finally, the leftover digit will become our fourth digit, which is only one single choice. So the number of possibilities using these 4 digits, where each of the digit is different from the other in a 4-digit combination, we can compute it using what we call the product formula in Excel. It just simply multiplies 4 into 3 into 2 into 1. If we allowed these digits to be repeated, in that case each digit will have 4 possibilities. In such a case, our answer will be 4 times 4 times 4 times 4, 256, when the digits are allowed to be repeated in the combination. Now let us look at situation where we are selecting only a subset of numbers from the bigger set of numbers. So we have, let's say, 4 digits A, B, C and D, and we need to select any 2 of them. There are several possibilities like AB, AC and AD. Right. Now we can select the first letter to be B, and we will have BA, BC and BD. Similarly, if we select the first digit to be C, first letter to be C, then we have CA, CB and CD, and finally DA, DB and DC. So we have a total of 12 combinations or 12 possibilities of selecting 2 letters from 4 letters. Now if the order in which these letters are chosen matters, then we have 12 possibilities. In case these do not matter, then we notice there are certain values which are actually one and same. So AB and BA becomes same. Similarly, AC and CA becomes same because there is no difference, and AD and DA will be considered same. Similarly, BC and CB will be considered same. BD and DB will be considered same, and finally CD will be considered same as DC. So when the order does not matter, we have only 6 possibilities. Now these can be synthesized in form of formulas instead of resorting to enumeration every time we need to do this counting, and those formulas are called as the combination and permutation formulas. So where n is the number of possibilities out of which we are selecting r. So here n is 4 and r is 2. So we already know that there are 12 selections possible when the order matters and 6 selections when the order does not matter. So when the order does matter, we use the formula called as NPR. Permutation is equal to permute out of 4 select 2. This gives us the answer 12. And when we have no concern about the order of selection, in that case we use the formula combine out of 4 select 2 and order does not matter, and our answer is 6. Let's solve another problem which will help us use the combination permutation formula directly. So we have 5 men and we need to select 2 men out of them, and 7 women, we have to select 3 women out of them. So now how many different combinations are possible when we have to select 2 men out of 5? I'll use the formula combine 5 comma 2. So there are 10 different possibilities when we select 2 out of 5. Similarly, we have 7 comma 3 combinations, which just gives us 35. Now for each combination of men, 35 women combinations can be attached. So we have 10 such combinations of men, so we will have total of 35 times 10, 350 combinations. So there are 350 ways in which we can select a committee of 3 women and 2 men out of 7 women and 5 men. Let's look at a little advanced version of this problem. Here in the earlier problem we had all the men and women were very distinct. Now in case we have the repetition of the certain elements or certain values in the data set, in that case how do we differentiate them? Let us say a bag contains 5 red and 5 green balls. So now point is, when you draw you have only 2 possibilities, a green followed by a red followed by green, both red or both green. Now which 2 red among these 5 red are chosen? Cannot be distinctly identified. So in such a case we need to reduce those canonical selections which essentially represent the same selection, right? So let us say we have these 10 letters, statistics, so how many ways in which we can select these letters to create new combinations? So let me put it here. This will help us efficiently count. Let me find what all unique values are there in the word statistics. STAINC. These are the 5 letters which make statistics. So let's count how many of each type are there. Comma S. So there are 3 S, 3 T's, 1 A, 2 I's, and 1 C. So in such a situation where we have these fungible duplicity or repetition of the same values within the data set, we use a special formula called as multinomial, where we can specify how many combinations are possible when we have 3S, 3 T's, 1 A, 2 I's, and 1 C. So we see we have 50,400 combinations or arrangements. Now let's solve another problem which involves the combination of these counting that you have learned so far to calculate the probabilities. So let us say there are 3 red, 3 green, and 3 blue balls in a hat. If 3 balls are selected at random without replacement, alright, find the following probabilities. So now we have to select 3 balls out of 9. And then we have to calculate probabilities of the different possibilities. So let us say we want to have 3 red, 3 green, 3 blue, and we want to have 1 each of these. I can sum it up to get the aggregate. We are going to select 9 out of 3. So how many ways in which we can get 9 out of 3? 3 balls out of 9 where the colors do not matter. So we have is equal to combine 9 comma 3. So there are 84 selections possible. Now out of these, how many of these selections favor 1, 1, and 1 of each color? So this can be counted using combine formula. Combine 3 comma 1. Now for each combination number of selections of red color, we have all possible combinations for green and blue as well. So we are going to multiply combine 3 comma 1 multiplied by combine 3 comma 1. So there are 27 combinations which favor 1 red, 1 blue, and 1 green. So probability is 27 divided by 84. I may represent it as a fraction, which may be easier to read. Okay, probably I need to go with 2 or 3 digits. Maybe I think 2 digits will be right. So 9 by 28. Now let's look at, let me kind of copy and paste it here for efficiency. Now we want possibilities of 2 blue and 1 red. So 1 red, 0 green, and 2 blue. You can simply copy this formula underneath here and that should work perfectly fine. So of course 9C3 is 84. Now 2 blue and 1 red is manifested in 9 occurrences out of 84, which can be simplified to 3 by 28. Similarly, okay, since I've already copied it here, now I want all of them to be green. So 0 red, 3 green, 0 blue. I'll simply copy the formula here. So there is only one way we can select all three of green in the selection process. So the probability is 1 by 84.